One number divides cosmology into two armies. Two teams, same universe, two different answers. And a crack where the standard model cannot hold. The gravity matrix. Two teams measured the same universe precisely. They returned two different expansion numbers. 67 kilometers versus 73. A decade of better data widened the gap. Neither team has surrendered its result. Something in the cosmos is quietly breaking. Here at the gravity matrix, we track the data. And today, we follow one number. The Hubble constant is expansion distilled. It tells us how fast every distance stretches. Edwin Hubble made the first rough measurement. His equation implied an impossibly young universe. Younger than the Earth beneath his telescope. Walter Baade exposed the calibration error decades later. Two populations of Cepheids had been confused. Every later measurement inherited that humility. Yet modern instruments revived the same puzzle. Adam Riess built the SH0ES program carefully. Edwin Hubble measured cosmic expansion in 1929. His number was wrong by 7 times. The implied universe was younger than Earth. Cepheid calibrations had hidden systematic errors. Walter Baade corrected the latter later. Every modern measurement inherits that humility. Which brings us to the present tension. Think about what a disagreement really implies. The universe cannot have two expansion rates. So one measurement must conceal a flaw. Or our physics must be quietly wrong. Now consider how carefully each side measured. The SH0ES team climbs a ladder of distances. Each rung calibrates the next carefully. Parallax secures the very first rung. Cepheid variables extend the ladder outward. Type 1, a supernovae, carry it farthest. Each transition introduces a tiny systematic risk. But the combined chain has been cross-checked. Now, a single anomalous result rarely moves physics. But this anomaly is corroborated many ways. This is the kind of result that endures. Because multiple independent methods converge on 73. Masers and water disks agree with Cepheids. Tip of red giant branch, stars agree broadly. Gravitational wave sirens hint at the higher value. But the CMB side is equally formidable. Planck measured the oldest light with surgical precision. And the Atacama and South Pole telescopes confirm it. Two pillars of modern cosmology measuring one number. And still the answers refuse to reconcile. For years this was called a puzzle. Then the James Webb data arrived. JWST reobserved the SH0ES Cepheid sample. Astronomers expected systematic error to appear. Instead, the measurement grew more precise. The expansion rate stayed near 73. The tension now reaches 5 sigma. Instrumental error is no longer a refuge. Think about what that conclusion forces upon us. Either dozens of independent teams share one mistake, or our cosmic model is genuinely incomplete. We don't know yet, and that is the point. Responsible science names its uncertainties clearly. Here is what to watch in the coming year. Euclid will map dark matter at unmatched precision. Vera Rubin Observatory will track transients nightly. Each new dataset narrows what the answer can be. Now the story tightens around one fact. No systematic fix has dissolved the tension. Dust extinction was proposed and rejected. Peculiar velocity corrections were proposed and rejected. Metallicity effects were proposed and rejected. The tension has survived every plausible systematic. Despite the headlines, this is not yet revolution. Preprints suggest many paths, none confirmed. Planck mapped the earliest cosmic light precisely. Its resolution exceeded every previous survey. The derived expansion rate settled near 67. Model assumptions carry the CMB measurement. SH0ES inherits distance ladder uncertainties instead. The two approaches simply refuse to agree. And that disagreement is growing more meaningful, because neither side has lost any precision. This is the strangest paradox in cosmology. A total measurement success that reconciles nothing. And now the crisis begins to define a decade. Consider what a 5 sigma discrepancy demands. In physics, 5 sigma is discovery territory. 5 sigma is what named the Higgs boson. 5 sigma is what confirmed gravitational waves. Now 5 sigma points at expansion itself, which is why independent methods matter enormously. Wendy Freedman built an independent distance ladder. Her TRGB method bypasses Cepheid calibrations. The result sits between the two camps. Some call it a peacemaking value. Others call it a systematic warning sign. Freedman herself argues for deeper caution, because intermediate values can hide two errors, or they can reflect a genuine new physics. Responsible cosmology refuses to pretend it knows. But something is clearly happening out there. Every dataset tightens the noose around lambdactum. The cosmological constant itself feels endangered. Einstein introduced it, then called it a blunder. Decades later, it was resurrected by acceleration. Now its very constancy is under question. Here is why the Hubble tension matters so deeply. If dark energy evolves, the early universe behaved differently. If new light particles existed, expansion accelerated faster. If neutrinos are slightly different, large-scale structure shifts. Every solution has a cost somewhere else. You cannot fix one equation without breaking another. That is why Dacey's dataset matters so much. Dacey measures expansion across billions of years. 4 million galaxy spectra provide the signal. Baryon acoustic oscillations serve as the ruler. And that ruler suggests the constant is not. This is the bridge into Part 2. But first we must honor what Part 1 earned. A 5 sigma expansion disagreement is not fashion. It is the kind of result that endures. It will shape the next generation of physics. Because physics advances at its most unsettled moments. The last time this happened, we got relativity. The time before that, we got quantum mechanics. Each revolution began with a stubborn measurement. Today that measurement is the Hubble constant. And we may be inside a revolution already. The evidence ladders we climbed are still sturdy. But the ceiling above them may be false. And beyond the ceiling is where Dacey looks. Part 2 of this series follows that beam. Because one number was only the beginning. Dark energy itself appears to be changing. 4 million spectra do not easily lie. Daisy has lit the next stage of the mystery. Every independent method would need shared error. Or dark energy behaved differently earlier. Both possibilities rewrite modern physics. Daisy's 2025 release tipped the scale. Dark energy may not be constant. Part 2 opens the door we feared. Because the cosmos does not owe us continuity. And our equations were only our best attempt. For now, remember the humility Hubble taught. 2 numbers and the universe hiding between them. In Part 2, the dark energy itself speaks.